IoT technologies. So generally this embedded system, so it takes the input and it gives the output. Okay, so to balance the input and output, there will be the one person who is the controller. So controller will place the major role to access the information or to send the information. Okay, so what are the major components of the embedded system? So the first phase is the RTOS, so real-time operating system, that is the OS. So what exactly it have? It have the in our laptops or the systems, the mobiles. We have the Android OS, or if it is a iPhone OS we have, right? Similarly, for the systems we have Windows 11 or Linux. So whichever we are using the OS. So OS, it will use for communication of the application software with respect to the hardware. Okay. So these are the three major components where the communication will be established between the hardware and the software. Okay, intermediate, we have the OS. OS, it is the middleware software with it is helping for the application as well as the hardware. What is a microcontroller? So microcontrollers are the small computing device. So where we are able to perform specific functions with the help of the devices. Okay, and it contains the processor, because some of the microcontrollers we can keep one processor, some we can keep 2 or 3 processors. Okay, so depends upon the application, we are integrating the number of the processors. Here the processor is the CPU, okay, central processing units, so where it will process the data. Okay, some of the controllers, it have the safety controller and application controllers in it. Okay, and we have additionally the memories, and we have the IOs. So IOs means externally we are configuring with the peripheral devices to communicate with the system. So you are able to see there is the block, the diagram of the controller, microcontroller. Here we have some of the IO ports and some of the memories we have some, and we have the processor. Okay, so it will process the data. And this is have the some of the connectivities where we are additionally externally we are configuring it, and we have a power so to communicate with the device. So how the controller we are communicating? So from the system we are connecting with the USB cable or some of the protocols. The wire communication will be there, and that we are connecting here and to the controller. And from the controller we additionally we are connecting the LEDs or the fan or the motor, so that will be the output. So input is what we use to simulate to the controller, and based upon the controller the input data, the output will be reflected. So what are the inputs and outputs? Generally the microcontroller, the inputs have the sensors, the digital switches, and some of the transistors. Okay, so analog inputs are the digital inputs will be comes under a part of the inputs to the controller, and the outputs are the display or the motor or speaker or the buzzer, anything that that we are receiving, so that will be a part of the output here we say. And these are the transmitters or the senders, so who will send all the analog input and the digital input to the controller. So and outputs are like the analog outputs and digital output. So these are the outputs that we are expecting from the controller. Is it clear? You are able to see there are display, motors, speakers, so all this will be a part of the outputs. So input devices, so just the devices of the sensors, whether it will be an analog sensor or digital sensor, and sometimes we use the keys or buttons to data controller, and the actuators and the motors or the displays will be the output, whatever we discussed now. And communication interfaces to communicate with other microcontroller you have the communication interface, because to transfer the messages of Forex or whatever the transmitting data or receiving the data, that can be happen. So that is a communication interface. So in diagram, we were able to see there are the control. Here we have the motor. So the additional motor, it have a different motor. We are configuring it here. And additionally, there are some other devices, the sensors we are connecting to it. Okay, and additionally the fan. So like just we are doing the connectivity of the devices to the controller. And whatever the analog input or digital input, so that we are giving. Here we have the data. So whatever the analog input or the digital output, so it will be converted. There will be the ADC. So whatever you are getting the analog data in the square waveform, it will be converted into the square pulses. Okay. So because the controller can understand only the digital data, so it will read as a 0 1 0 1. So whenever one comes, it will be the on state. Whenever it is off, means it will be the 0 means it will be off state. Okay. So if it is a continuous pulse, then means it will be the continuous on state will be there. But each here it will be split into the cycles. So like generally the cycle means it will be the one rising and one falling will be considered as a one cycle. Okay. So in case if it is the same with respect to the clock, like whatever the clock we are setting, right? So that clock is depends upon the cycle. Okay. So like consider I am keeping the 2 seconds. So 2 seconds is my cycle. Okay. So here how this 2 seconds will be covered. So this is one cycle, and this is another cycle. Means the 2 seconds here it will be the 1 second. Okay, and here there will be the another second. So here this is the 2 seconds. So this 2 seconds on means it will be on, it will be off, on, off. Like that, the rising and falling will be there. In case you don't have the, you should be always on. Okay. So this is a clock that we are setting it. In case whatever the signal you are sending on the with respect to the clock, we know that the synchronous or synchronous, clock dependent, the without clock dependent. Here the clock dependent, when we are sending the data with clock dependent, this is a clock signal. So it is rising and falling. Whatever the signal you are sending, it is continuously on. Means whenever you raised it, so it raised, and it is falling, it's not happened, it is continued. And whenever it is fall, so that time it fall down. Means with the 2 seconds of the cycle, it is continuously on. So this is the like a part of the signals, like we are whenever we are sending to the controller, so the controller will come to know that whatever the how many times on ones and zeros you are sending it. So this counter will take continuous data, whether you are reading it to 225 or 50 times the data you are sending. So that will be reading. Getting right? So how many, whatever the data you are sending, who will count how many bits you are sending the data? So that is a bit rate. So bit rate is the number of bits, number of bits, number of bits the transmitted per second. Baud rate is number of cycles, number of signals changes per second, number of B, number of signals or the bytes or the frames changes per second. That is a baud rate. Okay, and coming to the frequency, frequency is number of cycles per second. So you know the cycle is one rising and one falling will be the cycle. So frequency is the number of cycles per second. So this is very important. Sometimes interviews they will ask you. Okay, getting right. What is the frequency? What is the how the input signals we are giving to the controller? What then? Anil? Chakri.
Yeah, getting on.
Yeah. So now coming to the controllers to understand what are the basic components. So for the embedded system, microcontroller is the brain. Okay, it will decide the data. Who, what is the sensor you are getting the data? How you will need to send the data. It is the brain of the embedded system. Where controller processor is, it is a processor will uh, take the data and it will process whether it is the input or output. Okay, so the processor will play the major role. Okay. Microcontroller is a computer processor with memory and other IO peripherals on it. Okay, if you see the controller, generally the basic controller, Arduino controller, and so initially we have a history of 8051, that is a basic microcontroller. Oh, and now this is a user-friendly controller. Okay, similar to that, we have the analog input Atmel microcontroller, where the processor, other interfaces will be there inside it. And we have the TX and RX. Whenever you are sending some data, you receiving data, you have a LEDs, it will glow. And you have the reset button to reset the application. You have a USB connector, and you have the 5 volts regular supply. And we have a digital inputs and analog inputs. So where you can see send the data and receive the data, you have this A0, A1, A2 like this in diagram will be there. Okay, so we need to do some part of design, we need to consider the controller, we need to understand the pin diagram, and then you need to have the breadboard. So where you need to connect all the LEDs or the pins on the breadboard, and you have a battery and you have some supporting battery wires. Okay, with the help of this, so you can do some productivity. And we need to understand about the sensors. So as I told you, like we have the digital sensors and analog sensors. Okay, so inputs can be the digital inputs or analog inputs. So input whatever the digital things it will be the key switch buttons, and the analog is specific to the temperature or the pressure sensors will be the analog. And what is the sensor output? Sensor output will be the once it will be processed, the output will be in a digital way or analog way. So for motors, you need to rotate the motor, you need to send some digital pulses. Some speaker or any other devices, you need to read analog that can be monitored with the help of some oscilloscopes or some devices where we can see the square waveforms. It will be the digital, and some of the analog waveforms, it will be in the pulses where uh, that is generated from the controller. What are the communication interfaces? So communication interfaces are the USB port, Ethernet, CAN, and this is used for exchanging of the information from the one controller to the another controller. So with the help of the communication port, we are able to do the exchange information from device 1 to device 2. Getting right? So microcontroller, usually we have all this information and the CPU, RAM, ROM, IO ports, timers, serial ports, and interrupts. So just go in detail how the internally it's gonna configure. So it configure with the CPU, interrupt control logic, RAM, ROM, timers, IOs, and other peripheral devices. So how these are communicating internally? It has some wires. So that wires we call as a bus. Okay. So with the help of the buses, we are able to do the communication. And for the CPU, we have a oscillator. So that is the heart of the brain. This CPU is the brain. Oscillator is the heart. With the help of this, you are able to communicate the data. So history of the microcontroller. So just to aware, 8051 is a microcontroller. It was introduced as a 8-bit microcontroller in 1981, and it is the most popular and commonly used in various embedded field. Okay, and next is a part of the microcontrollers where we can see RAM, ROM, and other serial port timers. Or we have this 805 microcontroller is the hardware architecture because it's primarily for used for a specific design, and it is where it have internally some processors. It are micro levels, so that is a used versus CMOS technology we usually see. Okay, so what this 805 and microcontroller it have? So microcontroller it have the power, analog inputs, digital inputs, like whatever we saw that Arduino controller. Similarly, we have this. The port one, it will decide that some are the bidirectional, some it have the unidirectional ports. So you have in detail about the pin. Uh, you can go through this, the pin configuration. And next is the same like a ROM and RAM, IO timers, counters will be there. So just for your information, you can refer this pin diagrammatic. And whatever the pins we are able to use externally to communicate with the devices, we are able to do the programming and for flashing of the software, and we are able to do the debugging and testing with the help of the pins. With the and we are able to expand. We can additionally we can connect to the RAM and ROM, some of the other memories. So with the help of this pin, we have the issues in the pin is like sometimes the power with the whenever the high voltage is given, so the power with for that the pin get short or some burning can happen, and some input output current should be whenever we are rising we should be uh, careful, else it will be damage the controller. And next we have the voltage and current are the same, and interference whenever you are continuously transferring the voltage and current for long duration of time, it will heat up and it will get some electromagnetic interference such that the pin cannot work for long run. And pin conflict, so whenever you are using the pins for designing the circuit, you should be very careful, and what exactly the function you are using. If it is a sensor, you should use the sensor pin. If it is a switch, it should be used as a switch. In case it is a power where you need to give the power, you should give the power for the specific pin. So this is a standard block diagram for 8051. So in interviews may ask you, can you draw the block diagram of microcontroller? So this is a very important, you should have it. So the first phase is the CPU. CPU is the brain. Okay, in our human, it will be a brain, and oscillator, it is the heart. Okay, so heart is the continuous pulse will be generated. Okay, so with respect to the clock, okay, whatever the data we are sending, the data will be processed by the CPU. Okay, so here we have some data. That data you need to process with respect to the clock. Okay, so that clock pulse, the processor speed, if you say like 2.5 gigahertz, all that information means that specification you are saying based upon the clock. Okay, and processor will process the data, and it should have some RAM and ROM memories that will be in the controller, and you have a bus controller. So additionally, you are configuring some of the sensors. Okay, some of the enable features are power off or shutdown something or restart, so that you are doing on bus control, and you have some IO ports. So these are some parallel ports we have, and these are we are using as a serial ports. So that the T-X and the RX will be there where you are able to do transmit the data and receive the data where you are able to do with the help of serial port. And we have a timers. So timers is specifically count the event number of events, count the number of events. How this count will happen? Whatever the data you are sending from the serial port, it will count how much we received, and how much we are transferring, the counter will take, like it is a kind of a monitoring into the bus. So you are able to see there are some arrows. So these are like a arrows. It have a two ways, like transmit it can do, receive it can do. You can see there are some arrows which are unidirectional. It only transmit it. Okay, so this is about the block diagram of the microcontroller, and we have externally interrupts. So whenever the disturbance you are getting, right, so what the disturbance, what exactly you disturb, so that will be processed, then you will continue your interrupt. Is it's a kind of a disturbance, it will be created for the in hardware. Okay, is it clear? You are able to understand what exactly the microcontroller, what are the internal components of the microcontroller, how the data will be processed, who will act like a brain, who will act like a heart, and how this data will be communicated in the serial ports. It have two ports like TX and RX. How the counters will be, timer counters will be there. Is it clear?
Yes, sir.
Okay. So let's go in detail to understand of this microcontroller. So usually it have the CPU. So the CPU were able to see they have some data bus, address bus, and control bus. What the data bus will do, what address bus will do, what control bus will do. So generally the data bus is the one which carries the data. So that we call as a data bus. And the address bus is it has specific identity uh, to whom you need to send the data. Okay. So and control bus is whenever you are sending the data, how safe and securely you are sending the data. That is a control bus to manage the data. To manage the data is the control bus. So with whom you are able to access the data and identify the data, like who are sending. So with the help of the memory, with the help of the IO ports, you are able to exchange the information with respect to the CPU. Okay, is it clear? Okay, so we discuss what is a bus. Bus is nothing but a group of wires. Okay, so a group of wires where we used to exchange the data. So that we call as a bus. Like imagine here we have a four wires, small wires. So where we are sending the data. So like ones and zeros. Okay, so these ones and zeros are nothing but the voltages. Okay, so the voltages are going here in the wires, and so it will be the voltage will be the 2 volts or 1 volt or 5 volts, anything. So whenever it is rising, that time it will be 5 volts. Whenever it is falling, there will be no zero voltage. So like that, the data will be transferred from one device to another device. Device one, this will be the device two. Is it clear? So what exactly this bus control? It carries the control signals from processor to the other components. So it have three types, whatever the buses, how the data will be transferred from one device to the another device. So the three types are data bus, address bus, and control bus. So specific to the address will be identified whether I need to read from the address, whether I need to write the data to the address. So that will be decided. It is a bidirectional data where you are able to read and write. But whenever the data you are able to uh, read, okay, specifically it will be unidirectional. Okay, so where the information can be read from the CPU to the memory or peripheral devices. It is a single direction communication address bus. Okay, so it is specific from CPU to the memory or any other peripherals it have. Okay, so that it will carry, and we have a data bus. Data bus is the data we are able to exchange the data between the CPU and the memories. It is a bidirectional data transmission in both ways, from CPU to memory, memory to CPU. It will do the exchange information. That is a data bus. And control bus, it is a part of the manages the data flow between the send the devices, or between the memory to the CPU, CPU to the memory, how the data is exchanging. So it is a unidirectional. So it carries the information from CPU to the memory and peripherals. You are able to see there is a address bus and control bus are same. It will be where both will be unidirectional. Only the data bus will be the bidirectional. It have a two directional. Is it clear? What is the bus? What are the types of the buses we have?
Yes, sir.
So next part will be oscillator. So what is the oscillator? Exactly it will be. So whenever you see the controller, you have 20, it will be means 20 megahertz. Okay, something, it will talks about the clock. How many clocks you cycles you are able to send 1 second. It will be decided like a frequency. Is it clear? We discussed, right? Frequency is nothing but number of cycles transmitted per second. Okay, here 20 megahertz can be means 20 cycles can be transferred, 20 mega cycles can be transferred at 1 second. So that's what the 20 megahertz here it will be. So here, based on that, the processor speed can be decided. Okay, so based on the clock only, we are able to decide what is the processor speed. Okay, so what is the purpose of why we need to use? So it is a heart of the controller. We need to drive the microprocessor. So the CPU will be there, right? To process that CPU, to process the data, we require this clock. Okay, oscillator is used for timing of the various operations. So it is essential for supplying the clock signals. What it will do, it will instruct whatever based upon the data that we are receiving in the CPU. So according to the data, the clock will be decided. Is it clear? So the frequency oscillator, it will be vary from 0 to 40 megahertz. Coming to the CPU. So in CPU, what exactly it will be there? So it have many resistors and control units. So control inside the CPU, we have the control unit. Okay, so it is a brain of the microcontroller where the buses will be there. So buses, it have the data bus, address bus, control bus. So the data you are getting it to the control unit. So the controller will decide the data and it will process. Okay, so it have registers, program controller, instruct register, address register, accumulate register. What is this register? It has some space where it will do some logical perform operations based on the ALU. ALU is the arithmetic logical unit. Whatever the algorithms you are giving here, so that you are getting, so it will do some multiplication or addition, such kind of thing. So that will be the data that will be processed to the register, and it will exchange the information between the other devices and other memory devices. Okay, so that will be decided from the CPU. Is it clear? CPU takes the instructions in the form of program and execute them. What exactly CPU it have? So as I told you, it have the ALU, arithmetic logic control unit, and it will do data manipulation and it will control the task. And it will handle the interrupts, because the interrupts are the one it will events. Okay, so any kind of activity that you are suspending temporarily, so that is an event interrupt. So interrupts is the signal to the processor where interrupts can be happen towards the hardware or towards the software. Okay, whenever the interrupt occurs, what it will do? So it will go and execute the so there will be the ISR, interrupt service routine. So that will go and do the interrupt and it will come back. Okay, so that is what the interrupt will do. What the ISR will tell, so interrupt routine service, it will tell the processor, okay, what to do when the interrupt occurs, when you need to come out of it, for whether for the software or hardware, how you should do. what to do, like that will be decided by the ISR. And as I told you, like we have the hardware interrupt, so that we are giving externally. Software interrupt, it will be the interrupts that we are generating internally within the software, very specific to the programming we are interrupting it. What is the timer? So timer is specific to count the number of events. Okay, so how many signals we are getting and how the data you are able to transfer. So from the serial ports that you are able to read the data. It is used to count the events that happening outside the microcontroller or inside the microcontroller. Getting right? What is the IO ports? IO ports are the parallel ports. Are you all there? Okay, I'm not able to see, like I didn't got the response. So please respond. I'm going fast is fine that you are able to follow it.
Yeah, Mahendra, you can follow.
Okay. Okay, then. So then, thank you. So IO ports are the parallel ports, input and output ports, which are used for connecting the additional devices. Okay, with the help of that, what you will do, you are able to exchange the data and the signal information. Okay, input ports are which we are taking the data from the outside. So from the sensor or the switches. Output ports are where we are allowing from the controller. That from the controller we are able to expect some display or some of the motors to be rotated. That will be the output ports. So usually the parallel ports are we are able to see the US port, Ethernet, HDMI. So these are the some part of parallel ports in real time we use. And next we have the serial port. Serial port is in the real time view as a DB9 pins. So here we have a 9 pins connector, which is used for exchanging of the information. Okay, so what is the difference between serial and parallel communication? What is the difference between serial and parallel communication? Serial means sequentially we are sending bits. Parallel means multiple bits we are sending at a time, per second. Multiple bits per second, it will be the parallel. 1 bit per second is the serial, right? You are able to go in the topic or how? I'm not getting response.
Yeah, Mahendra.
Yes. What is a memory? Vardhan Chakravarti. And what is a memory?
It stores data.
Which stores the data. So memory, we have the random access memory. So it is a volatile memory that keeps the information only during the time it is power off. So it consists of program data. Okay. Then the application data, whichever the current users are working, we are able to write and we are able to read the data on the RAM memory. And we have ROM memory. ROM is read-only memory. It is a non-volatile. Okay, so where the information will be stored in this memory, it is a read-only. Okay, after the power is once the power is off, the data it will be erased. It is true. Once the power off, it will erase the data in the ROM memory.
RAM will be clearing. Mahendra garu.
Yes, ROM is read only. RAM is read and write. Okay, it's clear. But which one will store the data permanently?
RAM.
Okay, good. So it consists of instruction. So while like we have OS, right? We with the OS, or when we are configuring it, the OS will be configured in the ROM memories. Okay. So what it contains? It contains the instructions, how you need to run your application software. All those instructions will be added in the OS, right? In the operating system. So it consists of the instruction to execute the code and program the read-only data. Okay, and ROM, it have three many types. So the very important is the EEPROM memory, because in real time vehicles we are using the EEPROM memory. So here ROM is specific used for permanent storage. Okay, and we have a flash memory for flashing purpose, and we have MROM and PROM and EPROM. Okay, so these are the ROM memories we have. So going forward, we can understand about EPROM memory, what exactly we have. And next we have a cache memory. Cache memory is you are copying some data from with the help of the pen drive. So from that you are copying into your local system. Okay. So when you know to do this, right? So you should have a cache memory. And memo and other part is like in your mobiles also you used to delete some temp file, some scan, some delete. You will do the catch information data. And even whenever the systems are logging, it not able to operate for it is get the processor is getting low speed. So you have a temp option. Okay, so where you will go to the temporary folder and you will delete the files. So what exactly these files, how it is getting added when you are downloading the data from the net, or whenever you are using the copying or the data from folders to the devices. So that time this cache will be the part of the memory space. Here the data will be filled it. Okay, so that's why the system will be get slow. So the cache is a one memory. It is a part of the RAM memory. Okay, so it we call as a static memory as well. Okay, so usually it have the uh, varies from kilobytes to megabytes. So next, what is the peripheral devices which are we are connecting for the system computer, or similarly we are able to configure to the microcontroller as well. So to make the IOs like inputs and output devices that we are configuring it. So commonly we know that peripheral devices are analog converters, digital converters, or the clock, or the printers, hard disk, or some. There are extent information we have that peripheral devices which we are able to configure externally to the devices. So generally for the controllers, what are the futures? Whenever we'll go to the mobile, what is the specification we have? Similarly, the controller, when you are taking the controller, you should know what is the program memory, what is the data memory, how many registers it have, what is the software, how many software logs we are able to use it, what is the data bus, what is address bus, how many we have, and general purpose registers, how many we have, whether it is a 32-bit or something, and the timers which we are using, whether it is 8-bit or 16-bit, and the internal interrupts, like the external internal interrupts, how many we have, and how many ports we have. So just those information is required. So let's understand, like we have a controller, we have the device. So it's a camera. So the camera able to capture the information. So how you need to configure, we need to understand the pin diagrammatic, that is the schematics. So from the device, which pin where we are connecting it. The camera, it have the pin connection, and the camera controller, we have the pin. So with the help of the schematics, we need to understand, we need to connect the camera and the controller. Okay. And we need to do the programming. Okay. So how we need to create the embedded device? So simple, like we need to understand the programming language. We need to choose the board, and we need to understand what the requirement exactly. So whether you need to connect to the camera or any switch